Hi guys, how's it going? So these are your ion notes. So we have talked about the periodic table and the group numbers, right? And if you take a look at your periodic table at the top here, you will notice that we have group 1A, 2A, here's group B, group 3A on to 8. And something else you may notice at the top of your periodic tables, and I'm not sure if you guys have this one printed, but if you do, there are these pluses or minuses going across, but there's nothing here, and we'll talk about that later. So what that is, that has to do with valence electrons. And valence electrons from your atom builder activity, you may have looked at something and it may have asked you a couple of things about valence electrons. But what valence electrons are is they are electrons located in the energy level furthest from the nucleus. So if this is our nucleus, right? And so here's our nucleus. We have protons and neutrons in the nucleus. And then there were rings, according to the Bohr model, around the nucleus. And you had 2 electrons here and then a couple of electrons on the outer level. Well, this outer level, these are valence electrons. And they're the energy level farthest from the nucleus. So something that's unique about groups is every single group number, group 1, group 2, group 3, group 4, corresponds to the number of valence electrons in that group. So everybody in group 1 over here, group 1A, every single one of these elements in this group here, they all have 1 valence electron. So that means they only have 1 in their outermost level. Every single element in group 2 have 2 valence electrons. So they all have 2 electrons in their farthest outer level. So we can utilize that information to help us figure out ions. And ions are atoms with a charge, positive or minus, because they either lost or gained electrons. So if we think about it this way, okay, so if we take a look at lithium, for example, lithium right here. Lithium has 3 protons. And you've been told up to this point, well, if lithium has 3 protons, lithium also has 3 electrons in a neutral atom. And what does neutral mean? Neutral means 0 charge, right? Okay, well, what if we were to change the number of electrons? If we change the number of protons, that's going to completely change the element. But what if we change the number of electrons? What if we said, okay, instead of having 3 electrons, now lithium has 2 electrons? Well, our positives and our negatives no longer cancel each other out to make 0, right? Because 3 positives and 3 negatives makes 0. What if we have 3 positives and 2 negatives? Well, what does that create? If you have 3 positives and 2 negatives, you still have 1 positive left over. So we would say that that lithium has a charge of positive 1. Oh, shoot. Okay. So that's the way that this works as well. So all atoms want to have 8 valence electrons, right? We know that the noble gases over here, these all have 8 valence electrons. They're in group 8, so they all have 8 valence electrons except for helium. Helium only has 2 because it only has a total of 2 protons, so it's going to have a total of 2 electrons. And what do we know about the noble gases? Noble gases do not react, right? And they do not react because they have a complete outer shell. They already have it, complete outer shell. And that's why they do not react, because they already have 8 valence electrons. So every other atom on the periodic table, they want to be like a noble gas. They want to have 8 valence electrons. So what they're going to do is they're going to gain or lose enough valence electrons so that they can reach 8. All right, so group 1A, that is everybody in this group here. Group 1A, they have 1 valence electron, okay? Now, if we take a look at lithium, so if I have lithium, Li, it's got 3 protons in its nucleus. It has 3 electrons total. So in its first level, the most that I can have in the first level is 2. I cannot put any more. I can have less than 2, but I cannot have more than 2. So here's lithium's first electron, second electron. So its third has to go in this outer level here. Now, lithium wants a complete outer shell. Well, in the first level, 2 electrons makes a complete outer shell. In the second level and on, they want 8 electrons. So in order for lithium to have a complete outer shell, what do you think it's going to want to do? Do you think it's going to want to lose this 1 electron that it has here so that it has 2 in its outer shell? Or do you think it's going to want to try to gain 7 more? What do you think is easier? Well, think about a tennis ball. If you have 1 tennis ball in your hand, would it be easier to throw 1 tennis ball away? Or would it be easier to catch 7 so that you have a complete outer shell with 8? It's going to be easier to lose 1. So what group 1A is going to do is it's going to lose an electron. And if it loses an electron, right, if this electron goes away, well, now lithium, like I said before, has 3 protons and now it only has 2 electrons. So what is its charge? Its charge is +1 because it has 1 more positive proton than negative electron. So everybody in group 1 is +1. Okay, group 2A has 2 valence electrons. These have 2 valence electrons, and I'm abbreviating valence with VAL. Valence, VAL, okay? Now, if I look at the next element, let's do magnesium. Magnesium, okay, we know magnesium has 12 protons because its atomic number is 12, and typically it would have 12 electrons if it's neutral. Well, if that was the case, here's magnesium. So it's got 12 protons. In its first level, the most it can fit is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's got 8. 1, 2, 3, 4, 5, 6, 7, 8 in its next level. And then in its outer level, it has 2. So there's a total of 12 electrons here. Okay. Now it wants to have a complete outer shell. So to have a complete outer shell, it's either going to need to add 6 to this outer level or lose 2 so that its next level has 8. What do you think would be easier, to lose these 2 or to try to catch 6 more? Think about it in terms of tennis balls. It's easier for you to throw 2 away than to try to catch 6 all at the same time. So it's going to lose these 2 outer electrons, so it no longer has 12 electrons. Now it has a total of 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it has 12 positives and 10 negatives, what is its total charge? 12 positives, 10 negatives, that makes a charge of +2. So group 2A is +2. If it loses 2 electrons, it's going to have more protons, so it's going to be +2. Everybody else, group 3A, follows the same trend. It has 3 valence electrons. So what do you think its charge is going to be? It's going to be +3. Now, I know that your periodic table might tell you what these charges are, but you need to understand how they got that way. Now, group 4A. Group 4A has 4 valence electrons. So, just spelling it out here. 4 valence electrons. Now, if something had 4 valence electrons in its outer shell, what do you think would be easier, to lose 4 or to gain 4? Well, group 4A, it's just as easy to try and throw 4 as it is to catch 4. So they're going to do either. So group 4A could be +4 or -4. All right, group 5A. These, as we know, have 5 valence electrons. 5 valence electrons. And what do you think they're going to do? Okay, so if we draw somebody in group 5A, let's do nitrogen. Nitrogen has, in its nucleus, has 7 protons. So in a neutral atom, it would have 7 protons and 7 electrons, right? Okay, so let's draw the 7. Here's 1, 2. 2 is the most it can fit in the first level. 3, 4, 5, 6, 7. Okay, so it has 5 valence electrons. It's in group 5, 5 valence electrons. What do you think it's going to want to do? Do you think it's going to want to try to lose 1, 2, 3, 4, 5, or gain 3 more? What do you think would be easier for you, to try to throw 5 or to try to catch 3? Well, what nitrogen is going to do is it's going to catch 3 electrons, right? So if it catches 3, now how many total electrons is it going to have? It's now going to have 10 electrons. So now our atoms no longer have more positives than negatives. They now have more negatives than positives. Well, if something has 7 positives and 10 negatives, what's its overall total charge? Its overall total charge is -3. Why? Because it caught 3 negative electrons. So then everybody else, group 6A, 6 valence electrons. If it's got 6 in its outer level, it wants to gain 2, so it's going to gain 2 electrons. Group 7A, 7 valence electrons. What do you think it's going to want to do? Try to get rid of 7 or gain 1? It's going to gain 1. And then group 8A, they have a complete outer shell, right? 8 valence electrons. So what do you think they're going to want to do? 8 valence electrons. They do not have a charge. They have a charge of 0 because they do not need to lose or gain. They're already neutral. Okay, so this question here says, how many electrons will each group lose or gain? We already went over this, but let's go over it again. So 1A, what's 1A going to do? 1A, since it's plus 1, it has 1 more proton, it's going to lose 1 electron. Group 2A, what are they going to do? They're going to lose 2 electrons. Group 3A, what are they going to do? They're going to lose 3 electrons, right? They have plus 3, so that means they lost 3 electrons. Group 4A, they're going to lose or gain, they can do both, 4 electrons. Group 5A, what are they going to do? Group 5A, they're going to gain 3 electrons. That's how they became -3. They caught 3 negatives. Group 6A, what are they going to do? They're going to gain 2 valence electrons. Group 7A, they're going to gain 1 electron. And then group 8A, they're going to not going to lose or gain. No losing or gaining. All right. So we may have noticed that there are 2 types of ions. We have positives and we have negatives. Positives means they have less electrons. Negatives mean they have more electrons. Well, these 2 types of ions have names. The first we have are cations. And cations, these are the positively charged atoms. So they lost electrons. And a way that you can remember that cations are positive is because cations are positive, right? Because cats have paws. Really stupid riddle, but cations are positive because cations are positive, which means that anions, these are the negatively charged atoms, and these gained electrons, so they have more electrons than positives. And there isn't a stupid riddle to help you remember that anions are negative, but somebody once told me that anion looks like onion and onions are negative because they make you cry. Whatever, however you want to remember it. All right, so in order to form ions, it's really simple. All you need to do is write the symbol and then the charge. So calcium symbol is Ca. And if we find calcium on our periodic table, calcium is here in group 2. So if calcium is in group 2, it has 2 valence electrons. So what is it going to do with those electrons? Is it going to lose 2 electrons or is it going to gain 2 electrons? It's going to lose 2 electrons. So if it loses 2 electrons, what is its charge? It's +2. Fluorine. Here's fluorine. Fluorine is in group 7. So fluorine symbol is F. And fluorine, if fluorine is in group 7, right here, what is it going to do? It has 7 valence electrons. Is it going to gain 1 electron or is it going to lose an electron? It's going to gain an electron, so it's going to be -1. All right, nitrogen. Nitrogen is in group 5. Here's group 5. It has 5 valence electrons. What is it going to do? Is it going to lose 5 or is it going to gain 3 electrons? It's going to gain 3 electrons. So if it gains 3 electrons, it has 3 more electrons, so it's -3. And then last but not least, lithium, which we already did. Lithium is in group 1. So think about it. If lithium is in group 1, it has 1 valence electron. What is it going to want to do? Is it going to want to lose 1 or is it going to want to try to gain 7? It's going to lose 1 electron, so it's going to have 1 more positive than negative. All right, so utilize this information to help you figure out how to fill out your pen table, okay? You think about it, the group numbers will help you figure out what the charges are for these elements. Group 1, 2, 3 are all 1 plus 1 plus 2 plus 3. And then from there, plus or minus 4, minus 3, minus 2, minus 1, 0 charge.